Hello and welcome to my science tutorials. This is the part 3 of the dimensional analysis WASSCE past questions and answers. So without further delay, let's begin. So we have question number 1. The dimensions of moment of inertia are, and this is the options that we have. We have ml minus 2, b ml minus 1, c ml, and d ml raised to the power 2. And this is the WASSCE June 2013 question number 3. Alright, so let's have a look at the solution to this problem. So solution. Now, dimensional analysis involves the fact that the student has to know the formula for most of the quantities that we use in physics. So if you don't know the formula, you are going to be found wanting. So I suggest that you memorize as many formulas as possible. Alright, so inertia is given to us mathematically as mass multiplied by radius square, square. So the formula actually for inertia, let me use I, will be equal to mr squared. Okay, but I'm just writing it just because we are doing dimensional analysis. So the dimension of inertia will be equal to the dimension of mass multiplied by the dimension of radius, okay, which is a type of length, squared. So the dimension of mass is m multiplied by the dimension of L. Radius is L, it's just like length, so we have L squared. So our final answer here will be equal to ml squared. This becomes our answer for moment of inertia. So if you look at it, option D gives us that correct answer. Alright, let's have a look at another example. They said the dimensions of the gravitational constant G are, and then we have the options over here. This is the WASSCE June 2012 question number 1. Right, now if you don't know the gravitational constant, okay, now the force of attraction between two bodies, okay, is directly proportional to the mass of the two bodies and inversely proportional to the radius between the two centers of these two bodies. Okay, so let's look at the solution to this problem. So the gravitational constant, we can get it from, let me write down the solution. We can get the gravitational constant from the fact that force between two heavenly bodies is proportional to, okay, so let me use the proportionality sign. It's proportional to the product between the two masses and then the radius between them squared. Now if we remove the proportionality sign and we introduce a constant, that constant is G, which is the gravitational constant that we are asked to find the dimension for. So in this case, all we have to do is to make G the subject. If we do that, if we make gravitational constant the subject, we will have G is equal to F, which is force, multiplied by radius square, which is r square. I'm just going to leave it like that, over the product of the two masses that we have over here. So if I apply my dimensional analysis to them, I'll have the dimension for force multiplied by the dimension for radius squared over the dimension of two masses, so mass 1 multiplied by mass 2. Okay, so from here we know, okay, from all our previous example, that the dimension for force is ml minus 2, mlt minus 2, multiplied by radius is in length, okay, so we have L with the square over here attached to it. Then we have two masses, it will be m squared over here. So from here we can do some cancellation. One of the m will cancel one of the m's over here, we'll be left with 1. So we'll have the 2L over here, we'll have L1 plus 2. Okay, they have the same base, so we add the exponent, then t minus 2, and then we have m at the bottom. So if you look at it, our final answer is going to be, the top here will have L cubed t minus 2 on m, and this is equal to, if we bring m to the top, it will become m minus 1 L raised to the power 3, T raised to the power minus 2. This becomes the dimension for the gravitational constant. And if we look through our answers, we can see that option C gives us that answer, and so option C is the correct answer for this particular problem. All right, let's have a look at one final example. They said, which of the following dimensions represent impulse? Okay, so let's continue and have a look at that particular example. By the way, this is the WASSCE June 2017 question number 2. Right, so let's have a look at the solution. So impulse in physics is equal to the product of force and time. Okay, so if I apply the dimension over here, the dimension of impulse will be equal to the dimension of force, which we already know because we've seen it already, so there's no need to go through it again. Okay, we said that force is mass times acceleration. Okay, and then mass is m, acceleration is lt minus 2, and so the dimension for force is mlt minus 2, then multiplied by the dimension of time is t. So from here we have m l t minus 2 plus 1 from here, and so our final answer will be m l t minus 1. So this will become our final answer, and so option B over here is the correct answer for this particular example. So thank you so much for watching. These are some few objective questions on dimensional analysis that came from SSE time to WASSCE time. And thank you so much for watching once again, and I will see you in the next video. Bye bye.